Okay, this is Chapter 12, Section 1. This is dealing with statistics. The first three sections are going to be basically a lot of definitions. The last two are going to be a lot of math. It's really going to be a tough thing to explain. Statistics online. Statistics is the math involved is a little, it needs to be interaction. So we'll try to do the best we can. And I haven't decided if I'm going to give a project or a test. I will let you know. All right, so on page 747, if you read why this is important, it says, we live in an increasing data-driven society. Regardless of what profession you choose, it is likely that you will need an understanding of statistics to either read a report containing statistics or understand a graphical display of data. Okay, so businesses, biology, economists, all kinds of different professions require statistics or have statistics in them. It says this chapter will help you see the valuable uses of statistics and also recognize when statistical information is being manipulated or misused. So when we come over here, and this is on page 748, it says according to the American Pet Products Association, 68% of U.S. households own a pet. How does the organization determine this percentage? It would have been very expensive for the American Pet Products Association to ask people in every U.S. household if they owned a pet. Instead, to collect this information, the polling company asks a subset of households called a sample. If the American Pet Products Association did not ask people in every household if they owned a pet, how do we know that the American Pet Products Association's results are accurate? In this section, we will discuss different techniques statisticians use to collect numerical information, called data, and how they make accurate conclusions about an entire set of data from a sample collected. We will also discuss how to examine statistical statements before accepting them as fact. So basically what this is saying is that it's nearly impossible to always ask or take data from a complete population that you're interested in studying. And a population is the whole amount of individuals that you could go for. So what we do in statistics is we collect a sample, and there's different types of samples, and that's what this particular section's about, is the different sampling techniques. In other words, how do you get a representative sample of the population? So when we come down here, we have sampling techniques, and first thing it says is statistics is the art and science of gathering, analyzing, and making inferences from numerical information obtained in an experiment. So, this numerical information and these inferences, these are the predictions. So you got to understand that anything dealing with statistics is an inference. So, it's not necessarily always true. It says the numerical information so obtained is referred to as data. Statistics is divided into two main branches, descriptive and inferential. Descriptive statistics is concerned with the collection, organization, and analysis of data. Inferential statistics is concerned with making generalizations or prediction from the data collected. These inferential statistics are the main things that are influencing our society today. It says the entire contents of the box constitute the population. The population consists of all items or people of interest. The statistician often uses a subset of the population called a sample to make predictions concerning the population. Okay, it is important to understand the difference between a population and a sample. A population includes all items of interest. A sample includes some of the items of the population. Different type of, and make sure you understand that, We want an unbiased sample. Unbiased means that every individual in the population has a chance to be selected. A biased sample would be one where you arrange it so certain individuals get in the sample. All right. So a random sample is how we determine or produce a unbiased sample. If a sample is drawn in such a way that each time an item is selected, each item in the population has an equal chance of being drawn, the sample is called a random sample. So a random sample is, like I said before, is where every individual in the sample, in the population, has a chance of being selected every time there is a selection. We come over here. Now we talk about different types of sampling techniques. A systematic sample. A systematic sample is obtained by selecting a random starting point and then selecting every nth item in a population. For example, in a factory producing bicycles using an assembly line, a systematic sample could be obtained by randomly selecting a bicycle and then selecting every 20th bicycle thereafter. Okay, so it's picking a point, starting point, and then defining which one you'll select after. Cluster sample. Cluster sample is sometimes referred to as an area sample because it is frequently applied on a geographical basis. Essentially, the sampling consists of a random selection of groups of units. To select a cluster, we divide a geographical area under sections. Then we randomly select sections or clusters. Okay, so what this would be like is it would be like having a development, a huge development. Okay, and then putting the clusters in terms of streets, and then randomly selecting a street. Okay. Then we have stratified sample. When a population is divided into parts called strata for the purpose of drawing a sample, the procedure is known as stratified sample. Stratified sampling involves dividing the population by characteristics called stratifying factors, such as gender, race, religion, and income. So see, stratified is where we define the characteristic first, and then cluster is where we cluster a region. We cluster an area or something into regions and then take a sample. Convenience sample uses data that are easily and readily obtained. This is organizations that are going to make up their results anyway. So as a consequence, they don't care who gets selected or anything. This is like those individuals that walk down the beach or in front of a mall or shopping center, and they just go up to every individual and ask them if they'll take the survey. That's called a convenient sampling. In other words, they park themselves in a certain area and they ask everybody that comes by. They don't have any kind of method to the selection. Okay? So when we come here, this is identify the sampling technique used to obtain a sample in the following. So letter A says, every 20th smartwatch coming off an assembly line is checked for defects. So as a consequence, that's systematic. B says a $50 gift certificate is given away at the National Nurses Convention. Tickets are placed in a bin and the tickets are mixed up. Then a winning ticket is selected by a blindfolded person. And this is called random sampling. Children in a large city are classified based on the neighborhood school they attend. Random sample of 5 schools are selected. All the children from each selected school are included in the sample. This is cluster. The first 50 people entering a zoo are asked if they support an increase in taxes to support. This is called convenience. And the last one, all registered vehicles in the state of California are classified according to type, subcompact, compact, midsize, full size, so on and so forth. This is called stratified because they're based on the size of the car. All right, misuses in statistics. All right, when we talk about misuses in statistics, we have to look at, first of all, in terms of graphs. okay? Numbers can be easily manipulated, okay? In terms of this, here is a graph which is showing, and it's starting from 0 and going to 40, and it's showing a steady incline. Not a very good incline, but a steady incline. Here, this is where they've broken off, and I'm sure everybody understands this. This is where it still starts at 0, but we skip 0 through 24, so to speak. Not skip, but avoid them. And now we can see that if we go here, it looks like it's increasing quicker. Some other things, if you look at this, there's a way to manipulate graphs in terms of this is the real graph, and again, here's the break. Here is the graph in terms of, this little bit right here going from 95 to 100, okay? In terms of this one going 0 to 20. It's all in the way the graph is presented. Pie graphs are easily manipulated in terms of this. And so, like it says here, despite the examples presented in this section, you should not be left with the impression that statistics is used solely for the purpose of misleading or cheating the consumer. As stated earlier, there are many important and necessary uses of statistics. Most statistical reports are accurate and useful. You should realize, however, the importance of being an aware consumer. Especially in this day and time, I guess the big misuse of statistics is in politics right now, especially the polls they take. Beware, because you'll see someone like a news organization say that we took a poll and 45% believe this and 35% believe this. Well, if you add 45% and 35% up, that's only 80%. What happened to the other 20%? Plus, you'll notice that whenever you see these polls taken, they never tell you, number one, what population they took it from, what was the sample size. It could have been a sample size of 10, and they're making an inferential conclusion based on that. So be careful.